So now I'm going to use some numerical examples to show what I call the aggregate expenditure model, or the AE model. Sometimes it's called the Keynesian cross, but either way it's used to show the connection between spending and output, spending and GDP. Increases in spending increase GDP by more than the original amount because of the multiplier. Likewise, decreases in spending do the same thing. They decrease GDP by a multiplied amount. So whether you're pro-business, pro-government, traditional Keynesian, vice versa, export-oriented, sometimes you can say that there's a multiplier effect. It's useful for any type of policy, sometimes even more conservative policy if it's investment spending. This is the model. This is my consumption function, C equals A plus MPCY, and I've got a simple consumption function, $200 plus 0.8y. Now, what we're going to find here is that we're going to make the AE model that has spending, or AE, here, and GDP on this axis here. So what we're going to do is we're going to lay out two lines. So one of them is going to be A plus MPCY, or AE, which has an intercept here and a slope of MPC. This is going to be actual spending. It starts at A when it's 0, and then rises, but it rises fairly slowly. It rises less than a slope of 1. That's actual spending. Now the second line is theoretical. It's simply a 45-degree line with a slope of 1. So it starts at 0, and it represents any point where GDP and spending are equal. What this means is that it is a balanced budget. Right, so we're trying to make the rule of having a balanced budget where there's no savings and there's no something called dis-savings. So if you look here, you are spending more than you're earning. You have an income of 0, but you have positive spending. That's actually called dis-saving. You're taking money out of savings. That is not balanced budget. An individual would go broke. A country would wind up drawing down inventories of previously produced products and have nothing left to draw down. You run out of savings, countries can do the same. Here, if you have income higher than spending, you have saving, which is good for individuals, but it's important to remember that individuals can save money, but countries can't. If everybody saved money, if everybody was frugal, that means they wouldn't go out to eat, they wouldn't buy coffee, they wouldn't do a lot of things people do to save money, and those restaurants will close. So saving too much money actually can hurt the whole economy. So a country is best when income equals output, or income equals spending. So income equals AE. That's our goal. It's not too big and it's not too small. So this is what it looks like. It has a fairly flat line with a slope less than 1 but a positive intercept. It's got a theoretical combination of points, all of which are a balanced budget. $0 earned and $0 spent is balanced. $1 million earned and $1 million spent is also budget. You can make $1 million and not save any money and go broke, just like you can save money at a low income. So this is just simply any point where spending equals income. These cross at this exact point right here. Only this point is where actual spending meets that theoretical rule. So this point is where equilibrium GDP is derived. So this is where GDP comes from. This is the one point in equilibrium where spending and output are equal. Now, if I were to increase spending, I'm going to shift the whole line up parallel. All right, so my intercept growth, if I add money to this, which is what we'll do, we're going to add $100 to this. It's going to shift up the intercept, but not the slope. We're going to have a higher line that is still parallel, and if you look here, it crosses here. This is the new GDP in equilibrium. So an increase in spending leads to an increase in GDP. Now, this isn't super precisely drawn, but if you look, this is about an inch. This is more than an inch. That's the multiplier effect. $100 here would become $500 because 1 over 1 minus 0.8 equals 5. This is going to have a multiplier of 5 with these numbers. So in other words, 100 here becomes 500 across. So what we'll do next is we're going to lay it out with the grid, and we'll draw it, and we'll show how the numbers match. Here are my numbers. So I've got GDP going from 0 up to 2,500 in 500 increments, $500 increments. Consumption starts at 200 and goes up by 400. If this is rising by 400, delta C is 4, delta Y is 5. That gives us a slope of 0.8. Marginal propensity to consume is 0.8, 4 over 5. So as this goes up by 500, this goes up by 400, and eventually they're going to cross. So we're going to take our line here, we're going to start with our 45-degree line, y equals AE. And then we're going to draw the consumption function. Now, it's going to go from 5, 10, 15, 20, all the way to 2,500. And so it's going to start pretty small. It's going to start at 200. All right? But as we draw, we're going to see that it's going to rise in 400 increments. So at an income of 500, this is going to be 600. It's going to be slightly above. But if you add 500 to 500 and 400 to 600, you're going to see that they cross at exactly $1,000. And you can draw each point past this. This is going to be slightly below, and so forth. It's going to be slightly below. We can draw like this. All right, so this is going to be our actual spending line. This is aggregate expenditure. It's going to have a low or a high intercept and a low slope. It's going to cross at exactly $1,000. So if you see here, 0 with 200 spent is a savings of negative 200, and that violates the balanced budget rule. Income of 500 has two parts. This 200 is permanent, so we're adding 400 to 200, and so that gives us 600. Now we're still overspending, but we're only dis-saving by $100. Add 500 here and 400 here. Now we have 0 saving and 0 dis-saving. This is going to be equilibrium GDP right here. If we keep going, we're going to find that we have $500 more, $400 more here, which means $100 saved. And again, that violates the rule for a whole economy because you're not consuming enough to match your production. So you're going to keep going, the gap is going to continue to grow. So we only worry about this point right here. Now, this is equilibrium, and this is dis-saving, and this is saving. So this is our magic point. And next thing we're going to do is we're going to shift it. Now what I usually do is I just simply add plus G plus I, or plus I plus G, doesn't matter. And I'm going to say here, plus 50 plus 50. I made up $50 each just sort of randomly. This is 100 here. So if I move this over, this becomes 300. Now with a multiplier of with a multiplier of 5.0, an additional 100 should become $500 worth of GDP. And watch what happens. If we add this in here, we see this shifts up to 300, but everything else is the same. It's still rise over run, 400 over 500, 400 over 500. If you look here, now they cross at 1,500. It was 1,000. Now it's 1,500. And so in other words, $100 of additional spending becomes $500 worth of additional output. All right, so spending $100 more becomes GDP increase of 500 more, a multiplier of 5. You can draw it like this. Shift it up, and so now it crosses right at 1,500. So a $100 increase here becomes 500 across. Geometrically, you see that the upward shift is less than the horizontal shift. But the multiplier effect has to do with all the spending and respending of the same money. So these numbers show the run, or the increase in income, the rise or the increase in consumption. We see the intercept and the slope, and we can derive this line. If we add some sort of spending, we can shift the line up and watch equilibrium GDP shift over to the right more than the additional spending. Now, I'm not drawing it, but I could take this away, and I could subtract. What if I took 100 away all the way down? So I subtract 100 instead of add 100. And the answer is simply shift it down. I'm not solving it, but the equilibrium GDP will be 500. So in other words, taking away $100 from the economy shrinks GDP by the multiplied amount. So just remember that this is slope plus intercept form. This is this line here is the spending function. The crossing point gives us one equilibrium number, which is GDP. Changes in spending shift the spending line up and down and change GDP. So again, this can be used for government spending, which traditionally it is used for, but also tax cuts, investment, and even consumer sentiment. Black Friday, the day after Thanksgiving. If there's good consumer sales, you might see GDP go up as all the store employees spend their money elsewhere in the community. So I use it not only for its own impact and its own usefulness for policy, but as we'll see later, I'm going to use it to derive the aggregate demand curve for the ASAD model, and then in other classes I use it to derive the IS curve in ISLM and the DD curve in the AADD model or the DDAA model. So this is the aggregate expenditure model. It is the link between spending and output.